David Smith here with yet one more Flipped Classroom math lesson. 3 tips before we start. First, you can adjust the playback speed faster or slower to suit your desire. Second, you can pause the video at any point to jot down questions or catch up with your notes. Third, you can turn on the captions so you can read my words on the screen. Today's topic, the tangent line problem. Now this is a limits-based treatment of finding the slope of a tangent line. And as you recall, our last unit, we spent quite a bit of time looking at slopes of tangent lines, which we also remember are the instantaneous rate of change at a point, which is also the derivative at that point. So we're going to approach this time from a limit perspective, but we're going to get back into derivatives towards the end of this unit. So let's get started. So what I've done, actually let's take a look at this graph first. Here's the simplified version of what we're looking for. We've got some increasing function, probably exponential, and we have a point B, and we want to find the slope of the line tangent at B. So this is essentially what we're trying to do here. Now let's take a look and tease out the details. Remember, slope is the rate of change on a function, and it's the difference in the rise, which is y2 minus y1 for 2 points, and over the difference in the run, which is x2 minus x1. So all we need to do is jump on our graph and figure out what our coordinate points are, and then we can calculate the slope of this particular secant line. So let's take a look at that. To find the rate of change at B, to find the slope of the tangent line at B, what we do is we take a secant line and we move our A point closer and closer and closer to B until we're calculating the slope of a very, very short little secant line that will eventually approximate the slope of the tangent line at B. So I've teased this out quite a bit. This slope is not going to be really close to the slope of the tangent at B, but the diagram helps us see all the moving parts so we can create our formula. All right, so to do this, we need our x1, y1, x2, y2 so we can plug it into the slope formula. So point A, we're going to pick some value for x. We don't know what that is, but it's x. We put it into the function and it spits out f of x. So point A can be written just as f, or as x, and f of x. So that would be x1, y1. Okay? So that's going to be one of our coordinate points that we need for our slope formula. Now what we do to get to B is we move some distance along the horizontal axis, I'm calling that h, and now our new x-coordinate is just going to be x plus h. So I've written that here. Here's the x-coordinate of point B, it's x plus h. And then we take x plus h, we stick it into the function, and it spits out the y-coordinate, or what we commonly call f of x plus h. So that's our second point. That's our x2, y2. Okay? So now we're set to write a formula for the slope of this secant AB. So what I'm going to do is I'm going to write m of secant AB is going to equal y2 minus y1, so it's going to be f of x plus h minus f of x. So that's the change in y, that's the rise, and we can denote that here on the graph. We started here at f of x. I'm sorry, we did start there, but we have to subtract where we started from where we wound up. So here's where we wound up, which is f of x plus h minus f of x. So that's this distance. That's the change in y, or the rise. So we've got that on the top of our function. Now on the bottom of our function, what we have is x plus h minus x, right? We subtract where we started from where we ended up, and x plus h minus x is just h. So that's the slope formula for finding the secant of AB. And for any combination of x's and h's, and f of x's, and f of x plus h's, we can find the slope of our secant line. So that's the fundamental formula for getting a secant line, slope. Now what I want you to do is pause the video and think about what you know about limits, and think about what you know about what we have to do to get to the tangent line slope. Because remember, this AB, it's not close to the slope of the tangent at B, because our A is pretty far away from our B. In our last unit, what we did is we moved our A really close to B and calculated the slope for a really, really short secant line, and that let us see what the slope of the tangent line would be. So if you use that process and the concept of limits, you can write this slope as a limit. So I want you to pause the video and give that a shot. And take a minute or two. Pull out your pencil and draw some things. That's not right, scratch that out, try something else. Talk to somebody else, see what you can come up with. This is a really good chance to practice some critical thinking. Okay, let's see how you did. The idea here is that what's happening to H as we get closer and closer to B? It's getting smaller and smaller and smaller. At B, there is no H, okay? So what's happening is we're taking the limit as H approaches 0. Okay, so as H gets closer and closer to 0, we're taking the limit of this function here. So this is of f of x plus h minus f of x over h. And that equals the slope of tangent AB. Okay? So what we've done now is we've tied the work we did in our last unit into this new unit of limits. So one more time to summarize in case you're still kind of trying to get your brain around this. We have our point A, x, and f of x. Then we move h over on the horizontal axis. So now our new x-coordinate for this point is x plus h, because we've moved that distance over. And then our new y-coordinate there for that is f of x plus h. You just take the x plus h, stick it into the function, it spits out a y value. So now we have 2 points to calculate slope. We're looking for the slope of tangent, of the secant at AB. We have our x1, y1, our x2, y2. Here's our slope formula, which is rise over run. So we just subtract our y1 from our y2, and then our x1, our x2 minus our x1 ends up just being h. Then what we did to approximate the slope of the tangent line is we moved our a closer and closer and closer to b, which basically takes h closer and closer to 0. And what that does is that gives us this limit notation for the slope, which is as h approaches 0 of f of x plus h minus f of x over h. That's the slope of our tangent line. One last thing. This little piece right here can be called the difference quotient. So if you see questions in our book or on the homework or on a test or on a quiz that reference the difference quotient, what we're talking about is this little equation here where we're talking about the slope of secant AB in this notation. Okay? Okay, let's do a practical problem using what we just did on that last board. Okay, so what we're going to do is we're going to find the slope at a point. This is the slope of a tangent line at that point. So here's our function. Basic quadratic function, nothing special about this. This is just f of x equals x squared. We're trying to find the slope of a line tangent to the point at negative 2, 4. Just as a review, here's our function, basic parabola, vertex on the origin. Here's our point, negative 2, 4. We're looking for the slope of that tangent line. So first off, you could tell it's negative, right? We have a decreasing function, so the slope of the tangent line should be negative. So when we're done with this, if we end up with a positive number, we know we're not correct. Okay, so let's take a look. As a review, here's from our last board the slope formula for a secant line. It's f of x plus h minus f of x over h. Okay, so check this out. Let's do our plug-in. We know we're at the point negative 2, 4. So the slope of the secant is going to equal f of negative 2 plus h minus f of negative 2 over h. Okay? So I just did my plug-in. I plugged in my x value where x shows up in here. Now I have to do the math on that. This is f of negative 2 plus h. So we're going to take this term, throw it into our function. So let's do that. This is going to be negative 2 plus h squared. So we're going to get, we're going to FOIL this. Let's just do it out. Minus 2 plus h times minus 2 plus h. That's what that is. We just plug that into our function. And this is going to be minus negative 2 squared, okay? And then all over h. So the bottom of the fraction just stays pretty simple for a little while. So let's take it down one more line. M secant is going to equal. Now I could FOIL this, and I'm going to get 4, that's first. Outside is minus 2h. Inside is also minus 2h. And last is h squared. And then bring over our last term. So this is negative 2 squared is 4, but we're subtracting. So this is minus 4 all over h. Now this gives you a feel for the algebra that we have to do to evaluate these. This is a really simple function, but already it's starting to look a little bit complicated. If you stick with it and work on it hard, you'll be able to cancel the right terms so you can ultimately evaluate your limit. Okay, so let's simplify. I have a 4 and a minus 4. Those go away. So I wind up with minus 4h plus h squared over h. Now, thinking ahead, to find the slope of this tangent line, we're going to have to be able to evaluate the function when x is 0, or I'm sorry, when h is 0. That's our bottom. So right now, we can't do that. If we plug h in, we're going to have a divide by 0 problem. So we still need to do some work to get to the right place. Fortunately, it's not so bad. So check this out. Slope of the secant. Now on the top, I can factor an h out of both those terms and get h times minus 4 plus h. I just took an h out of both those terms, all over h. Now I can cancel, bink, and I have my slope is h minus 4. Okay? I just switched the order of those. So let's finish. The slope of the secant line is the limit as h approaches 0 of this, h minus 4. Now I can use direct substitution to evaluate this limit. If h is 0, then my limit is just going to be negative 4. And there we go. And guess what? It's got a negative slope. Remember in the beginning we talked about it had to have a negative slope. So we're there. We got our negative slope. So there you go. That's a practical problem using a simple quadratic function to find the slope of the tangent line. And again, this algebra is super important. It's nitpicky. There's a lot of steps. And this is a simple function. They get harder. So just be really careful with your record keeping. And remember that what you're shooting for is a final product where you can cancel out that bottom h so you can evaluate the limit. Okay, so a year has passed since the segment that you just watched. I've got different clothes on. I'm a year older, but the content is still the same. So I decided to put in another example so that the homework is a little bit more clear, a little bit more easy for you to do. I also updated the homework key so that it's a little bit more easy to follow. So let's do this. So here's another function to check out. Instead of x squared, we're going to do x squared plus 2x. This adds a wrinkle to our process, and it makes the record keeping in the algebra much more complicated, and you have to keep track of that so you get to the right result. So what we're going to do is we're going to do x squared plus 2x at the point 315. So we're going to use this limit process to find the slope of the tangent line at 315 on this function. So let's start with that. So the first thing is we're going to do f of 3 plus h, that's our x coordinate, minus f of 3 all over h. Okay, so that's the setup. I haven't really done much algebra. I'm just doing f of 3 plus h minus f of 3. And remember, ultimately what we're going to do is we're going to run h to 0, take the limit, and that'll give us our tangent line slope. Obviously, can't do that with h on the bottom. So now let's do the plug-in step. Now this is probably one of the more tricky steps involved here. So what we're going to do is every place we see the function, we're going to use the terms that are up here. So watch this. So f of 3 plus h is going to be 3 plus h squared plus 2 times 3 plus h. So I just plugged in 3 for my x-coordinate plus h everywhere we saw x in our function. So this is x squared plus 2x. Now what I do here is I subtract just plain old f of x with no h's. So I'm going to put a minus. I recommend use parens there because it's going to affect some signs. And here we go. We just have 3 squared plus 2 times 3. So that's just f of x. So that's just f of x when you plug 3 in for x. And this is, of course, all over h. So yeah, pretty complicated, lots of algebra to do. All right, so let's analyze this. I'm going to bring it down here. 3 plus h squared, this is a binomial, this is a familiar expansion pattern. What we're going to get from that is we're going to get 9, that's the 3 squared. Our two terms in the middle are going to be 3h, so that's going to be plus 6h, and then our end term is going to be h squared. So that's what happens when you expand that binomial. Now let's do the next one. That's 2 times 3 is 6 plus 2h, that's 2 times h. Now minus, I'm going to bring in my parens. It's going to be 9, that's the 3 squared plus 6. Actually, you know what? I'm just going to take care of this. Let's take off the parentheses. It's just going to be 9 minus 6 because that's 6, but that negative also applies to that. Now this is all over h. Okay, so now we get to do some crossing out. We're not yet at the cancel step, but notice how I have a positive 9 and a negative 9. Those go away. And I have a negative 6 and a positive 6, so those go away. So now let's rewrite this. What I have is, and I'm going to combine my h's. I have a 6h and a 2h, so I've got 8h. So I got those done, and I have my plus h squared. And that's all that's left on the top. Pretty simple. All over h. Now I can cancel. I have an h in every term, so this h goes away, it cancels that one, and it cancels the squared on that h. So this ends up being 8 plus h. Wow, look at this. I mean, very complicated, lots of terms, boils down to just 8 plus h. And now the limit's going to be super easy to take. Let's do that. It's the limit as h goes to 0 of 8 plus h. And this is super simple. When h is 0, the limit is 8. So in this example, on this quadratic function, at the point 3, 15, if you draw a tangent line at that point, the slope of that tangent line is 8. Now that you've watched the video, take a moment to jot down extra notes or jot down some questions for our next class. You can also re-watch portions of the video that you didn't get the first time. If you enjoyed the video, please click like, and if you'd like to help me grow my YouTube channel, please click subscribe.